Hey folks, I thought I'd make this really quick tutorial. It's going to be in 3 parts, and so let's go ahead and get started. So our first part, I'm going to explain a little bit about how the HC SR04 ultrasonic module works. This is going to be very important because if you ever want to do more than just the regular sonar stuff, you're going to want to know how this stuff breaks down. Okay, so first of all, of course, the ultrasonic module works on the principle of sonar, which is where one of the speakers, the transmitting speaker, we have the receiver here, the transmitter sends a signal, and the signal takes a certain amount of time. Now, normally, and remember that since this is an echo, we want to divide it by 2, and that should be able to give us a distance. It's going to be a rough measurement, of course. And remember that the speed of sound is 340.3 meters per second. So, and in feet, it's 1125.3 feet per second. Now let me show you how this all works. So first of all, let me go ahead and draw you a quick timing diagram. And here is our trigger. And then here is our transmit speaker. And then our echo, to give you an idea. Now this is not exactly to scale, but it kind of should give you an idea. These two are kind of similar, at least in this logic. So the trigger gets turned on for about 10 microseconds. That's the time it needs to activate. Once it turns off, the transmit speaker will send out 8 pulses very, very fast. And these 8 pulses, here we go, about 10 volts, will then, as long as it takes for the echo to receive them, it will then give a signal that is roughly proportional to that time. And so we can measure that. Okay, so if we wanted to measure that, we can go ahead and calculate that distance. So let's go ahead and note. So we trigger for about 10 microseconds, and then it goes off. Now we get our time, like I said, from the echo. Now remember, this is a pretty simple equation, but basically what we're doing is we're getting time, and we're going to divide it by pace, and that will give us distance. Okay, so I will give you an example to give you an idea. So if we have 340 meters per second, and 1 meter is equal to 100 centimeters, 1 second is equal to 1 million microseconds. If we do the quick conversion here, we're going to notice that we're going to have 10 to the 4 over 340, and let's cancel out, make sure we have microseconds over centimeters. And so that's going to give us 29.39 microseconds per centimeter. That's our pace. Or, I'm sorry, that's our time. Okay, so if we have 1 second over 1125.3, 1 is 12 inches. Okay, 1 second's 10 to the 6 microseconds. And this is going to give us 74.05 microseconds per inch. So that's how long it takes to cross this distance. Okay, now we're going to use these numbers later on in our calculations, because basically this is going to tell you how long it takes. So when you measure time, you're going to want that. Okay, so let's start our first wiring diagram. Now here we're going to, normally our Arduino sketch, we're going to define our trigger and our echo variables. Then we're going to set up these same ones. You know, this is the kind of stuff you've done all the time, where we set our trigger and our echoes. And then in our loop, okay, first part of the loop is to turn on the trigger for 10 microseconds. And we turn it off. And then we listen. Now, the duration, we're going to use this in our calculation, so we're going to plug in a little calculation that's going to say our distance is our duration over our pace times 2. And remember, it's times 2 because we have to split that distance in half. Remember that this is half the distance. Now, I strongly recommend you write this all on paper because if you're simply following me blindly, you're not going to get it. I repeat, you are not going to get it. Now, the next part is just a rule to exclude values that are out of range. And if we do get a good value, we're going to print it, and we wait a half a second and we loop. So let me show you how we wire this. So first we start off by adding our power. So that's our +5, and then here's our ground. Okay, and then we're going to add our trigger to 4, and then we're going to add our echo to pin 5. Here we go, 5 and 4, and that's our 5 volts, and that's our ground. Now let me go ahead and show you how we really wire it up in reality. So here's our parts, the Arduino, the SR04, and our 4 wires. Pretty simple. Okay, so first off, let's go ahead and plug this in. Let's put the Arduino up here. And the first thing we do is we plug in our power wires. Here we go, power. Our trigger, here we go. And then our echo. Okay, now I'm going to type up our basic code. So we define our variables. Okay, and then we set up our serial, our trigger, and our echo pins. And let's go ahead and define 2 new variables, duration and distance. And then we're going to turn on the trigger pin for 10 microseconds and then turn it off. And next we're going to define duration as the pulse-in function of the echo pin, the listening. We're going to define distance as duration divided by that number that we got before. So that's going to give us centimeters. And let's set our condition in case we have something that's out of range. Remember what I said. If it's out of range, then the serial will say that this is out of range, so we can't do anything with it. Otherwise, remember these if-else loops. Okay, so we're going to print the distance, the variable distance, and we're going to print centimeters after it. So keep an eye on these if-else loops because we're going to use them a lot. We're going to delay about half a second. Now, we're not plugged in, so let's go ahead and plug this in. Okay. So now that we're plugged in, we're going to go ahead and, there we go. We're going to upload. And there we go. As you can tell, when you get the box close or far, you can see the distance changes. Wonderful. So everything's working with our simple setup. Now let's go to our more complicated setup. This time we're going to use the sensor, the Arduino, LCD, and 2 LEDs. So first off, our sketch. I'm going to try to keep the things that we've done before in blue. This time we're going to add an LCD, and we're going to add our 2 LEDs. In our setup, our trigger and echo are going to be the same, but now we're going to add an LCD and the LEDs too. And in our loop function, okay, if you remember, a lot of this is going to remain the same. We're just going to add extra functionality to it. So we're going to listen for 10 microseconds, and we're going to call this our duration. Oh, I'm sorry, we're not listening for 10 microseconds. Sorry about that. And our distance is our duration over pace. Now, here, we're going to go ahead and create an if-else rule for our LEDs. Keep that in mind because you may want to do other rules. Say if you wanted to do 3 LEDs, that might be useful. We're going to use our rule to exclude low and high values. And if the rule is not exceeded, we're going to print the value. And this time we're going to print it to the LCD. We're going to wait a half a second. So let's go ahead and try this out. As always, we start off with our power connections. Okay. So here we have our power on 1, or I'm sorry, our ground on 1 and on 5 and on 16. Okay. And then we have our ground here, we have our power here, we have 15 and our power on 2. Okay, and our 4 is our register select to 7. And then our 6 is enable to Arduino's pin 8. Then 11, this is our data, which goes to pin 9. Then 12 is pin 10, 13 is pin 11, 14 is pin 12. And our echo is going to go to pin 5 over here. Our trigger is going to go to pin 4. Then we're going to draw our volume here. And our pin 3 will go to our volume, or it's our contrast knob. I just keep calling it volume because it looks like one. So our LEDs here, and our red LED is going to go to 3, and our green LED is positive is going to go to 2, and the negatives, of course, will both be ground. These are both ground. Remember, though, that the resistors there are 220 ohm. You need them if you don't want to blow out your LEDs. Okay, so let's go ahead and set this all up. So first things first, let's go ahead and just make sure everything is kind of using up the right amount of space. Okay, and we go ahead and start plugging in the power wires. So our grounds, our reds. Remember, power wires are almost always should be the first ones you try to plug in. Sometimes you can't because you have other things, but whenever you can, try to keep everything and use the same colors. I've seen too many knuckleheads switch their colors and then they wonder why they're getting so confused. Color coding is useful for a reason. Okay, so here we plug in our volume, and now that we have our volume, we plug in the power, the plus and minus for the red. There we go. And then we plug in the plus and minus for our sensor. And then we're going to plug in our register select into pin 7. Then our enable from pin 6 to pin 8. And I always try to just plug in all my data pins at the same time, or well, in order. So here we go. Here's our data pins, our 4 data pins. And here we go. And our final. Okay, now we plug in our main power. Okay. And our trigger pin. Here we go. And our echo pin. Oh, here we go. Yeah, everything starts to get a little messy, but as you notice, it's not that messy. But okay, good. So now that we have this, we can go ahead and add our LEDs, starting with our, here we go. And we add our resistors. Okay, now we add our LEDs. The short lead goes to the resistor. The long lead is going to go to the wires here. Oh, I got the short wires. Okay, I'm going to take these 2 wires out because these were meant for the LEDs. I'd already planned this out. So I'm going to replug in the ultrasonic sensors wires. Same connections, nothing new. Okay, and now we actually have room for our LEDs. So let's go ahead and wire this through. Here we go, our red LED. And our blue LED, or our green LED. Okay, So I'm going to go ahead and rush through the code to save you some time. If you really want to see the code, you can go ahead and pause the video and you should be able to check it out. Just here I've added our liquid crystal, our trigger pin, and our red LEDs. Then we set them up accordingly. Everything should have the same logic. I'm trying to keep everything organized here. We add our, much of this we've already done before, where we set up our distance, we calculate this, and we set our condition for anything that is out of range. But this time, if the distance is within range, as you noticed, if it's a certain distance, we turn one light on and the other off. If it's another distance, we set one light on and the other off. Now here, notice we added the LCD set cursor, the LCD print command, okay, and we set up on both. We try this out. Oh, I made a mistake. I don't have a semicolon. Now I plug this in, notice, and voila. Let's just change the contrast there. And as you can tell, if I have a little box that I'm getting closer and further. And as you can tell, everything works. So I hope this helped. I'm going to create another video, but if you got any questions, let me know, okay? Okay, take care.